Okay, so I'm Christophe de Dinechin, and as you know, today I'm going to talk about DB48X, which is a project I started about 2 years ago while stranded in Berlin due to air controller strike. And I've been working on it since then. So the idea is to revive what I call the spirit of HP calculators. And I define the spirit as being better than the best. And I'm going to explain what this means. Also, DB stands for, can you guess? Remember what H and P were? They tossed a coin.
Bill and
Hewlett and Packard. And that's Dave and Bill in the opposite order. So that now Dave has the first row. So, the agenda for today, I'm going first to discuss a little bit about the HP nostalgia that we all have, and why is there a museum of HP calculators. I'm going to give a very quick overview of what DB48X is, and then I'm going to focus and deep dive on how to build a better user interface, how to do better computations, how to do better libraries, and how to do better performance, and again, then whatever exists today. So, let's start with the HP nostalgia. So, as you all know, even with TI calculators, so when we have good products, that makes good memories, and that's the reason we all have these good memories about HP calculators, that they were consistently better than anything else that was on the market at the time. And that's why we have these good memories. So why this HP nostalgia, and why did I keep using the HP48 as an engineer for years, 30 years after buying it? So the HP35, for instance, was better than the best slide rules of the time because of electronic computations. The HP65 was better than the best fixed function calculators because you could program it. The HP34C was better than the best explicit calculators because it had a solver and numerical integration in it, so it didn't have to explicitly mention things. The HP41C was better than the best closed calculators because it was open. It had this magic XEQ key that you could use to execute alpha and enter any command. So now you could have libraries that would be used exactly like anything else, and all the connectivity, HPI, etc. The HP15C was better than the best scientific calculators on the market at the time, with integration of complex numbers, matrix computations, and so on. The HP28C was better than the best numerical calculators that were available at the time. The HP48SX was better than the best, period. And arguably, that's still holding. I still think that's the best HP calculator ever made, and I'm going to explain why as we go along. So, my personal bits of nostalgia. First of all, I was lucky enough to meet both Bill and Dave in person. So this is the picture of the day I met Dave Packard, and the guy that you see at the back here, looking not at the camera but looking at the great guy. I remember what I was thinking at the time. I was thinking this guy gave some work to 100,000 people. That's the Uber engineer, that's the Elon Musk of the time. This guy created the Silicon Valley.
Do you remember which year this was?
Sorry?
Do you remember the year?
The year for creating the Silicon Valley? No, I don't remember.
No, I know that.
Oh, the year for this?
Yeah.
That was 91. I think.
He died in 96.
Yeah. So, I could go on the story here over pizza. The bit about his visit was really fun. Now, I mentioned the mobile mutuality, mobile electronic shops and the discussions. This is the book written by Paul Corbis. This is not the original. The original was for the HP28. That's the HP48 version. And in the HP48 version, he introduced a program that I sent to him called MuSolver. And MuSolver is the MSLV function that appeared later in the HP50G, etc. That's the same thing. And Sergey the publisher actually used more or less that code to make it work, as far as I know. It's something very similar. And I mentioned that I was writing cross compilers and writing games with it. Should move like this. Yeah. So this is one of the games that I wrote. That the recording is not mine. It's someone playing the games 30 years later and recording it on YouTube. And I found that fascinating. It's, I think, the Calculator Culture YouTube channel.
Is that the Australian guy that does this?
Maybe. I forgot. I can try to find where I picked up the video. I'll try to find it for you. Also, interestingly, I never wrote the HP48GX version. Someone else did it. So there was this spirit of people hacking software that written by others to make it run. So for instance, the 48GX version is not mine.
Well, there's another exceptional thing about this.
Yeah.
It's not the green display, it's the black display.
Yeah. So, now after I was also unlucky enough to go through the downfall of HP with Marker and California. And so a time where HP calculators could look like this, so the HP EasyCalc 100, better than what? Than nothing, I guess. But the HP 6S, that's the 2020 School of Science. It's really horrible. We had the HP 42, so I'm going to get some flack for this, but the reason I'm bringing it up is that because it's the return of RPN. So this meant that HP thought, oh, maybe RPN is not the right way, and we need to return to old roots. And I argue that it's because they did the 48GX and made it wrong, and that's the reason. And the HP48G or GX, what is wrong in this calculator is that they started inventing the notion of apps, making the user interface mode, so you would change the way to use the calculator depending on what you wanted to do. And because of that, it's actually more complicated to use than the 48SX. For the same feature set, the feature sets on the 48G are more complicated to discover. They are hard to find. And if you want to see a recent trend in computers that is exactly the same thing, it's on macOS, now the buttons appear only when you move the cursor next to them. It's infuriating. You can't discover the buttons because they are hidden. You need to put the mouse next to it to see the button appear. That's really annoying. The HP50G, so that's this one here. So that's the last big RPL machine. With something really interesting is that in order to reuse the old code designed for the 7 processor, while this machine has an ARM processor, so what Cyril and his team did is implement a full 7 emulator on ARM to run the old ROM code, which is just amazing. But what is annoying with this calculator is that it was RPL becoming a subject of shame, so that HP would sort of hide it. The calculator starts in algebraic mode, and it has a few things that it does correctly only in algebraic mode and doesn't do in RPL at all. And I really don't like it. And the way you see that RPL became shameful is that the enter key is here. Completely wrong spot, very small, absolutely useless. The prime, so that's this calculator, that's the last large calculator that HP did. So it has color, it's very fast, it does remarkable 3D graphics, it's really neat. But for instance, the function keys that are here, you have to touch them on the screen. So no tactile feedback. It's really horrible to use in practice. Plus, and I'm going to talk about this, that's the next topic. Policymakers have killed the engineering calculator. There once was a time, and Bob Prosperi, for instance, brings that up regularly, there once was a time where HP would finance engineering features with students. Students had to buy a calculator, so they were in a cash cow, and that was used to develop stuff that they would use later. So you'd buy an HP calculator as a student, and you'd keep buying HP calculators as an engineer because you were familiar with them. And that model stopped when they started passing legislation against cheating, copying, blah, 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 clamping down the calculators, and then HP and others had to make a choice. Do I select the engineering market or do I select the students market? They all went for the student market for obvious reasons, because those are high volumes. And that means you have calculators that are designed for teaching how to do things and not for actually doing them. So as engineers, they are not good at all. So after that, HP began milking the cash cow and capitalizing on nostalgia, because that means excellence in terms of cash flow every time. So they started playing the same old card again and again and again, always keeping the same old designs.
I have that.
So yeah, the question is that better, still better than the best, or is that still the best being repeated? No longer inventing new stuff. That's bad. Fortunately, third parties came to the rescue and went beyond the decades-old hardware, 3 decades old for the HP48SX. Notably, by having simulators on smartphones, you can run. My smartphone has a Fate 41, a Fate 48, a Fate 67, a Fate 70, all sorts of calculators that look cool and are really fun to use. In terms of hardware, companies like Swiss Micros have redesigned, recreated the old designs, and their business is really to do exactly the same thing as the original. But a few tinkerers, folks who like to do electronics for fun, have started going a bit beyond, for instance, creating an HP15 with a bitmap display or things like that. And in software, we are going to hear about how to reprogram an HP20 into an WB34S. So you have a number of folks who started thinking maybe we can do better than what HP shipped on the same hardware. Or, so that's the case for new RPL. For instance, new RPL is a new implementation of RPL for the HP50G. And that is way, way faster than the original because it's not emulating the old code, it's writing new code from scratch, etc. The problem is that all these tiny steps, that's one small step. It's not always a giant leap for mankind. We stopped making any kind of progress in calculators. So what I wanted to do was a giant leap. I wanted to move forward because the spirit of better than the best, as far as I can tell today, besides what I'm doing with DB48X, only exists in the WP43 and C47 projects, where they are trying to say, what can we do that is new, that is useful, that makes us efficient. So, what is DB48X? Very simply, I'm trying to make the best scientific calculator in the world. Period. There is a period at the end of the sentence. That's the objective. And in order to do that, the first step is to revive what I found was the best interface for advanced calculators, and that was RPL. So that means reviving Hewlett-Packard's reverse policy list in the spirit of the HP48SX, not GX, not in the spirit of what is found on the 50G, etc. No apps, no models, etc. And do that on modern hardware from Swiss Micros running on iPhone. So it runs on iPhone, you can download the app on the iPhone if you want. And I'm going to make an Android version at some point. So a quick primer, how do you do that? How do you reinvent the best calculators in the world? First, the inspiration was, there's a hardware platform where I can do stuff. And that's the DM32 and DM42. So I just zapped the old firmware, replace it with my own. The specifications for the project, that's easy. It's the HP manual with an S at the end. Because the problem is that you have the user manual that tells you more or less how it's supposed to be used. But then you have all the reference menus that are very skimpy on details on how it actually does things inside. Sometimes they use things that are completely wrong, so you have to choose between what the calculator does and what is written in the manual. And of course, they don't say the same thing between the 48, the 49, the 50, the 28. They all have slightly different versions of how to do things in RPL. To give you just one example, do you know how many flags I need to be able to correctly emulate the way to display numbers on various generations of HP calculators?
You mean like from points.
Yeah, so trying to emulate what all HP calculators do.
20?
I think that I'm slightly below 50 now.
50. Oh wow.
So you have, for instance, whether when you have a decimal number beginning with 0, whether you display a 0 or not. All HP calculators except the HP48SX display 0. HP48SX displays dot something. Whether you have spaces, whether you can support a dot, a decimal dot, etc., but also whether you display separators or not. And one of the very first I'm going to show it, one of the very first requests I had was for displaying separators. So I have all sorts of flags to try to mimic what various calculators do. And for instance, the rounding, the fixed mode, is not the same at all between the prime, the HP48, and the HP28. They don't display the same thing when you say fixed 3 and you start going down in terms of exponent, they don't display the same thing. So I know the various versions and I know how to recreate it with various flags. So RPL stands for Reverse Polish List or Wrong Programming Language, or there are various other interpretations of the acronym. I like Reverse Polish List because it highlights the strength of the language. It fits in a calculator, but it's a very, very powerful programming language. Lisp is something that is called homo-iconic. It's a language where you can have a program write programs, or manipulate programs, or exchange them. You create a list and you turn that into a program. And that makes things very, very powerful. It means you have a command line, you have menus, you have soft keys, you have an infinite stack, also many data types, and there are way more in P48X than on the HP calculators. And that's where it starts in terms of enhancements of HP. P48X is in the spirit of, which means doing better than the best, not sticking to exactly what HP calculators do. So I'm not running an existing ROM. I'm not running any kind of existing software. I want to do the same thing but better. Now, when you say better than the best, you have to define what is the best, who's the best, which is the best of the calculators. And of course, nobody agrees. There are folks who love the 15G, the 15C, sorry, folks who prefer. So,
what is RPL? Is it a bit similar to Fort?
Yeah, it's
many samples.
Yeah, so it's actually, it could be called Forth. It's extremely similar to Forth, except that Forth manipulates only integers, essentially. At least the original Forth. And the innovation in RPL was to say the stack is going to point to any kind of object. You can have a matrix on the stack, you can have a complex number, you can have text, you can have stuff like that. And every object is tagged with a type. And so when you do an operation like plus, it knows that if you have two complex numbers, it must do a complex operation. If you have a complex and a real, it has to promote the real to complex and return a complex, all these kind of things.
That's the difference. So the prologue testing is 24 different types it has, or something like that.
Yeah. So
the prologue testing is the one that determines where to go next, which is not RPL anymore.
So okay, if we go into the details of the implementation of HP's RPL, HP RPL was doing something that is extremely smart and inspired from Forth, by the way, which was that objects were actually the format of an object was an address followed by a possible payload. The address was simply the address of the program executing the object, evaluating the object. And so it's called a prologue, and so when you compile a Forth program, typically what you get is a series of addresses, and running the program is very easy. You load the first address, you jump to it, at the end of the code that is there, it loads the next address, jumps to it, and so on. And having a payload simply means that the program then is reading the data, or executing the data, like let's say you have a real number. The program is simply going to say, oh, I have a real number, it's 12 bytes after that, for instance. So I just skip ahead 12 bytes and I don't fetch the next, the the next address, but I jump 12 bytes to the next object. Now, this works for executing the program. And the smart in HP's implementation of RPL was to say that, oh, what we could do is to use these addresses as a sort of dispatch mechanism. So instead of always executing the program, you can instead decide to skip the object. So you can compute its length. Or you can decide to display it. Or you can decide to... So you have various things that you could do with this same program simply by varying. hp48x is completely different. I'm going to... It's not in the presentation. I can answer how it's done, but it's not in the presentation. So, my favorite, my personal best. By the way, I know you started that already, but this is designed to be an interactive talk, so please interrupt me at any point, and you don't have to follow that along.
The only thing I'd say is, those of you that heard me in the introduction, Bill Wiggis, you heard the name? No. Yeah. He designed RPL. He was the one.
Yeah. This is a really smart design. And initially it was designed, hence the name ROM programming language. It was designed as a way to make the ROMs more compact, because it's essentially a way to encode very quick calls to subroutines. So you can make code that is really dense, and that was initially how it started. It's only much later, I think, with the 28C, so that HP17B, for instance, was using RPL internally, but just it was not exposed to the user. And the 28C, the famous experiment that was supposed to fail, was the guy saying, hey, what if we expose that to the user? What if we put a compiler, an RPL compiler, as a command line, and expose that to the user? Would that work?
And that was Bill Wiggis.
And this was genius. This was genius. So, my favorites, HP48SX, the best RPL experience to me, still holding after 30 years. Well, second best now with DB48X. HP50G, that's the best RPL feature set, has an incredible catalog of functions, some of which are really mysterious, things that only a mathematician could love, because you have no idea what they really do. But also very good system level access, like it has a complete assembler inside, it has a complete system compiler, etc. You can do tons of really funny stuff with that. The HP Prime has very good graphics. It's also, in my opinion, the best keyboard, not in terms of touch. The touch is very good, but in terms of how it's organized, you immediately see the layout just from the colors. You see exactly, you know, there is one part for computations, there is one part for, and that's really neat. Something that I think Swiss Micros should learn from at some point. New RPL is this project that runs on HP50, a bit like what you are going to show WP4034S. It's a firmware for existing HP calculators. In that case, it's an RPL replacement for HP50G. And that was an inspiration for a lot of work done. As a matter of fact, DB48X, the very first iteration, was a fork from New RPL. And then I was very happy, I got where I wanted to go. And at that point, I said, okay, let me buy a DM42 and try to fit it in. And then I realized that my new RPL binary was 1.5 megabytes and I had 700K only in the DM42, so it was twice to me. Oops. So that's why I started from scratch. But one of the things that new RPL did that I found amazing is that they had variable precision in a calculator. So you can compute on 200 digits. And I thought, oh, can I do that? And I did. The GM42, I really like the form factor. I like that it feels sturdy, that it has this really gigantic screen compared to what we used to have in terms of pixel resolution, etc. It's really neat. You can do tons of good stuff with that. And WP43 and C47 are another family of alternate firmware for these calculators, the DM42, the DM32. They are RPN instead of RPL, so this means they have a fixed size stack, they have, but they borrow a number of ideas from RPL, like you can put a matrix on the stack, for instance, things like that. So it's good that we have someone trying to do the highest end RPM possible and someone doing the highest end RPL possible. So that way you can pick what you prefer. So I want to embrace the best and reject all the stuff that I don't like. So for instance, you may have seen this little cursor here after that. This is the busy cursor on the HP48, and the user of the HP48 says, I say it's the best experience except for the fact that it's super slow. Just adding two numbers takes forever. So there are a number of things that I don't like in each of these calculators, despite the fact that I like them, and so I just evaluate what I don't like. On the GM42, for instance, I don't like that they don't have an alphabetic keyboard. And by default, it's ABC with the menu keys, because that's the way the HP42 does. They fixed a bit of that since then. Okay, so let's start with, I could pause that here and wait for the pizzas, or if you have questions.
The pizza is coming in 15 minutes.
Okay, so let me start with the user interface and then we'll stop at the next section. So, how do you make the calculator easier and faster to use? Let me start with the guiding principles. And what you see on the top right it's very small, but it's the cover of the Macintosh Human Interface Guidelines. And it's a book that any engineer working in any kind of user interface should read. Because it explains tons of things, like how do we make things easy to discover? The notion in the Macintosh that you could just go to a menu and explore and click at random, just to, you go to other menus to see what are the features in this program. The Macintosh in particular. That's how you discover features. Or the idea that when you want something to apply on an object, you select the object, then you click on the menu or the button or whatever that does something to what you selected. The Macintosh invented that. They always tell you, that they stole stuff from the Xerox PARC, etc. This specific aspect comes from the Macintosh. It did not exist before. And I know because when I was a student, we had a teacher who was also designing, it was the early days of graphical user interfaces, and he decided to do it backward. He had the Macintosh's RPM. You select the object, you apply the command on it. And decided to do it algebraic. So you would select the menu and then select the objects the operation applied to. It's a nightmare. It's an absolute nightmare. So, one of the principles is to avoid siloed modes. All kinds of subsystems, all kinds of apps. The things that do not communicate with one another. So for instance, the HP Prime, despite the fantastic hardware, has a computer algebra system that you cannot use in RPM mode. It's one or the other. You have to choose. That's really annoying. Or if you do graphics, you cannot do computations. And if you do computations, you can't graph them without dragging a program. That's really silly. But all HP calculators had something like that. For instance, you're all familiar with polar and rectangular modes for displaying, for instance, when you're doing
complex numbers.
Vector computation. Sorry?
For complex numbers.
For complex numbers, etc. Well, why do you need that? With RPL, you can make another choice, which is to have a polar complex number on the stack, a rectangular complex number, and the software can display both at the same time. And when you add them, it decides whether the result is polar or rectangular, based, for instance, on the one that is at the bottom of the stack. Another design principle is to be as consistent as possible across all features. This means, for instance, that the multiply key, you have an RPL program at the top. That's one of the aspects of RPL that is great in terms of not being moral, is that in RPL, you don't have a program mode. You have program objects on the stack that you edit like anything else. And you manipulate your programs like anything, you store them in variables, etc. It's completely orthogonal, it's the same way for everything. So now this is a small RPL program, so these chevrons here are beginning and end of program. And otherwise it's RPL inside. So 2, 3 multiply, A 3 multiply, a text A 3 multiply, a vector 1, 2, 3, 3 multiply. And that gives me these results. So for instance, I can multiply the text by 3 and it repeats the text. So this is what makes RPA in relatively useful to use. Now, discoverability, I told you about the menus where you click to find the functions. Something inspired by new RPA is to have a catalog. Now, you may remember the catalog in the HP41. There was a catalog in the HP28 S and C. I think they dropped it in the 48SX and they revived it in the G, if I recall correctly. In any case, you have this catalog of features that lets you relatively easily find something. You vaguely remember that the function contains this or that name, and the way this is implemented in DB48X is you type something in the command, and it shows in the menu everything that begins with the command. So, for instance, catalog. And then, if there is anything that contains the command, it shows it afterwards. So, for cat, it shows you catalog at first, because that begins with catalog. And then it shows you duplicate all the things that contains cat. Also, it's very important to focus on efficiency for common use cases. You're doing something that you do often, and I use as an illustration one of the keys that I changed, that on the DM42 it's a sigma plus here for statistics. So I reassign that to this magic button, what I call the tool menu. And what this does is essentially it takes the thing on the stack and it picks up the menu that corresponds to what you have on the stack. I'm going to show that in the demo in a moment. And also, make sure that when you don't remember exactly how something works, there is some built-in help that shows you a detail. So you have a complete reference manual inside the calculator itself. Complete with examples. I'm going to show how you can actually execute examples, which is something really useful. So let's start with the small stuff, the simple things, data entry. Request 3 months after launching the project, a guy tells me, you know, the old HP calculators, the 17, etc., they have spaces when you enter large numbers. I can't deal without spaces. No RPA calculator had that before because the RPA text editor is just a text editor. So now I have to have a text editor that is smart enough to recognize numbers and insert spacing inside and skip the spacing when you go backwards, etc. I fixed the bug like 2 weeks ago. Well, delete right after a space would not delete correctly, so I had to fix that. But it works now, and it's really neat. It looks cool, because now your numbers look great, and of course you can configure how many spacing and so on. The Chinese people use 4 instead of 3, so you have to configure all that. Another example is... So, another cool thing that exists, for instance, on the HP 32, I think the HP 32 has something like that, where you can enter GLS values easily. And no other HP calculator has it. So if you have this calculator, you know that you can use dot multiple times to enter GLS values. That's neat, so I copied it. So you see you type dot a second time, and it turns it into degrees, minutes, seconds. And now you can do your angle computations very, very quickly, because you just add 2 angles. That's what I do here. See, I'm just adding 2 angles in 2 seconds, without extra keys, without anything. Okay, I'm a software engineer. I'm working on base numbers all the time. That was one of the big use cases for my HP48, was to add hexadecimal numbers or things like that. Well, when you type base numbers, you have in hexadecimal A, B, C, D, E, F. So what does the calculator do? As soon as you start entering the hash sign, the cursor changes to a B for base numbers, and when you type A, B, C, D, E, you don't need to shift or enter alphanumeric or anything. It knows that you're in an hexadecimal number, and so you type your base number very quickly like that. By the way, if you look carefully in the example, that's one thing where I deviated from HP. is that HP had this postfix notation behind it where you say H for hexadecimal, T for decimal, etc. I decided to borrow from C47 and use a suffix like this instead. And what you just saw, you missed it, but you can enter in any base and display in any base between 2 and 36. So you can enter a number in base 3 by saying 3 hash something. So I'm entering binary here. Why be in, so this is a ternary word. Algebraic expression, so RPL, the sheets were the first ones in the HP line that really supported algebraic computations well. Yeah, and so in order to make this easy, so you simply type, you have a tick key that is here in the top left corner. Another guiding design principle, by the way, that is, I forgot the name of it, but it's the fact that things that are in the corner are easier to access. And so if you have something important in a user interface, you put it in the corner, or top, bottom, left, right, because you hit there. And so the most important keys are the tool menu, entering an expression, on, off, exit, and getting the catalog or adding stuff. So the most important keys are in the corners. So you enter algebraic expressions. Now I have this problem that the HP42 has 6 less keys than the HP48. So I have to rearrange the keyboard, and this is why a number of things that are done with different keys on HP48 are done with a single key that changes meaning on the VM42, and it's based on the context. This is an example where once you're inside an algebraic expression, you don't need a tick anymore. What you need is parentheses. And you don't need parentheses anywhere else in RPL. And so this key inserts the ticks when you're outside an algebraic expression. When you're inside, it inserts parentheses. Same thing with the key at the bottom here. Also, very important key. There is an equal key in on the B48X. That's also evaluate. That's the thing that evaluates a program, or evaluates an expression, or evaluates something. So you enter your algebraic expression the right way, and then you hit eval, or that's essentially equal, and it gives you the result.
When you hold is, I'm getting an allergic reaction.
That's fine. Call it eval.
So that's why you can just put eval. Now it has a third meaning. It has a third meaning that is if you're outside, if you're editing, so you don't have an empty key. If you're not editing, then it evaluates what is on the stack. But if you're typing something, then it inserts a space. So, but you get used to it super quickly. Okay, text entry is very important in RPL because RPL doesn't have number registers, it has variable names, which is overall neat, but this means you need to be able to type text. So there are multiple text types, and there is a dedicated alpha key that you can see here on the HP RPL calculators. I did not have space for an alpha key here. So in order to fix that, there is 3 ways to enter alpha mode. Shift, enter, the largest key. So you enter alpha mode that way, and you can enter lowercase. And then you can hold shift. So if you hold it for more than half a second, then enter alpha mode. But then I discovered that the calculator could read 2 keys at the same time. And then it hit me, and I invented something called transient alpha mode. So I don't know. So what this is you hold the arrow key, and then within half a second, you hit an alphabetic key. And so if I go, oof, I got an A. Now with the left arrow, that's an uppercase A. With the right arrow, it's a lowercase a. So I invite you to try it and see how this works. So that's a transient alpha mode. I can only show it in real, because I can tell you on screen, but if you don't try it, you don't understand how it works. Command completion is what I showed about the catalog. So when you're in alphabetic mode and you hit the plus key, then it enters the catalog, and you can use that to autocomplete. So you simply use then the function keys to autocomplete one other command. There is also a character menu. So when you are inside the typing some text, you have the second shift on the 2 key, it says char. And that's a list of menus with various categories of characters. We have musical characters, we have music, you have Greek, Cyrillic, etc. French, of course, because you need French accents. So now what is interesting is that if you enter the Greek or Cyrillic menus, then the keyboard layout begins transliterating in that language. So for instance, if you type A while in the Greek menu, then you get an alpha. Now if you want that A, you can type A again, and the reason for that is that it actually cycles through variations of the character for A, alpha with an accent, A, alpha with an accent, A. And all this is configurable, so you can configure that for your own keyboard if you want. There is also a character catalog, and that works slightly differently, but it's the same principle where you hit the plus key while typing text. And you see, if you are next to a C, it shows all the variants of C. C with an accent at the top, etc. So if you're typing Czech, where you have this C with accent, and I think no other calculator in the world, not even C47, has that. Okay, so menus and soft keys are really
A short question for me.
Yeah.
What we see in the presentation, is it a regression testing program you have written to see how it's interacting, or?
So I'm going to show the regression testing program, but no, those are part of the documentation. Those are part that are not published yet because I recorded.
Okay, it's pictures you are.
Yeah, so these are pictures that I actually recorded specifically for this talk. I did another set of pictures for a frozen talk again earlier, but there were way more to show that did not exist. And so I record the screen, and then I play it back with, it's the same video played back twice, that's the full video, and then I'm zooming on this section so that you can see what's inside. And so you may ask, how do you do that in PowerPoint? And the answer is you don't. So what you see there is the software that I created with my video software. It's called Power Presentation, and that's what I use for presentation. Yeah. So the menu keys, so you have F1 to F6 here, and these are soft keys that are defined by the menu here, and the shift key, in order to have as many features as an HP48, but with only one shift key because I have no room for two. So I borrowed an idea from WP43 and then C47, which is that if you hit shift twice, you get a second shift. So hence the little color, which is also part of the logo. So you see the logo has one yellow dot and two blue dots. And that's one dot is shift, two dots is right shift. And so I invite you to test it if you want to check some functions. That gives you access to a fairly large number of features. Now, the HP48 and other RP calculators have a next key, because sometimes you have more than 6 functions, or more than 18 in my case. And so the dedicated next key is one of the things that went away due to lack of space. And so the choice instead was, if there is more than 18 features, then the menu system shows a little arrow that you see on the right. You're going to see that up here. Yeah. So that's what you use to get to the next menu. Then there is the tools menu. So the tools menu, as I mentioned, selects the menu that corresponds to what you're working on at the moment. So this means, for instance, in that example, I have numbers initially. Cycle back. So see that the menu that I have in the tools menu depends on whether I have the unit, the text, and the etc. It's a very convenient way of doing operations quickly. Now the vars menu gives you access to all the variables in your current directory. So you can, for each of the variables, you have unshifted function evaluates what's inside. If it's a program, for instance, it runs the program. That gets the value out, it recalls the variable, and that's stored into the variable. So that idea is borrowed from the var menu in the HP48, where you store and recall with the left and right shift keys. But there is also a custom menu and no space for the custom key. So how do I do that? Well, I do that with var. So if I'm in the variable menu, I don't need var again. So if I hit var a second time and there is a custom menu defined, then I see the custom menu show up. The custom menu, for those of you who are not familiar with RPA, is a menu where you put whatever you want. So it's the stuff that you use often. And because menus are used so often, there is a menu history, so you can go back to the previous menu up to 8 levels. But it's smart and reordered, so it never has the same menu twice. So if you reuse a menu, then that menu will bring you back to this one, but then you won't see it again in the history. Now, the reference manual, it's an interactive reference menu. That's what makes it fun and to make it easier to understand rather complicated stuff. So an idea that I borrowed from GNU RPL, but that exists in the HP41. So what happens in the HP41 when you hold a key? Do you know that?
It shows the function
It
first,
shows the function.
and if you keep pressing, it cancels.
It cancels it. Yeah. So here it's the same idea, except that cancelling is by showing the help for a function. So then you exit the help and you've cancelled the function. So if you're familiar with the 41, you'll find this idea. And it's a much better way to invoke the help for features than whatever exists, for instance, in HP Prime. This works, holding. Oh, yeah, you're playing with it. I thought maybe
No help for stack menu. I tried the help on stack,
yeah,
and it says no help for stack menu.
because I did not document this one yet.
I found the one.
Yeah. So
Does the help compete with the functions in terms of memory usage?
no, because the help. So the help is stored in a file on the disk space. So you can. It's optional. If it's not there, then you're going to have the no help for blah 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 message. You install it if you want, and it's written in Markdown, which is a sort of document description language that is fairly easy to parse, and that GitHub recognizes. So this means that the help that you have in the calculator is also online.
Yeah.
But it's also online. It's also on the website. It's the exact same, because when I build something, I publish the same help file on GitHub, where you find it with the browser, that is installed in the calculator. And by the way, this is where there's a call to arms for you guys is talk about this project. One of the things that needs help is the help. Like, there are missing entries for obvious things, like you hit the stack key and it doesn't find help.
How much space does help take?
So, what takes space at the moment is that we are putting BMP illustrations, that's 12K per BMP. So we are...
Like dynamics or the feather or thermodynamics or
Yeah,
like the solve equation count.
Yeah, exactly. So, but there are, so for instance, let me show you, let me take, for instance, the constants menu. So, shift const, and then I see mathematical constants, and then pi. I hold for pi, and then you see that I have an illustration for pi.
Ah, okay, yeah. But then, yes. I know you can't compare, but I'm thinking about in the 35, they had 1,000 words to make the math. Today, the documentation for that takes 10 times the space of the actual math.
Yeah. And so this is why it's an external file. And the reason also it's an external file is because it also documents items in the library. And items in the library are things that you can add yourself. Of course, the library is something you can put your own library stuff. And so the help file is actually built from pieces that are assembled together. And if you decide to create your own library on your calculator, you can add a section that will be added to the help file and will be used exactly like the rest of the documentation. So right now, I think that the help file, you can check that right away. Just so you see that it's 11,000 lines and 39.1K. So 391K. But if we take the pictures into account as well,
That explodes.
that's 1.6 megabytes to go.
How much memory do you have?
That's on the GM32 today it's 6 meg.
Sorry?
It's you have 6 megs of flash space available. So I'm using a lot for that help file, and we can decide to change that. So the help command explains the objects on the stack as well. So if you want to know how decimal numbers work, you can simply put a decimal number, hit help, and you get help there. And I noticed that the information about decimal numbers is obsolete because it doesn't take into account the variable precision stuff. The help has hyperlinks and a history, so you can move forward following links, move backwards using backskey or the backtopic function key, and you can export the help that way. As I mentioned, there are graphical illustrations, so that's the pie example. And there is testable sample code. So when you have a gray section like this, you hit enter, and then you put that on the command line, you hit enter again, you execute it. And you can edit it before executing it to see what happens if I change this or that parameter. So this is the example for the grub, to-grub feature to show what is the impact of the font parameter. And so I invite you to try it if you want. And as I mentioned, it's markdown, so you have the exact same thing online. Object editing. So remember what I told you at the beginning about having things that are as orthogonal as possible. Where RPL is really great is to say, we have a command line, the way you edit objects, whether you edit a number, whether you enter text, whether you enter a program, it's all the same. This is different from the modes you have on an HP41, for instance, or HP33 or whatever, where you have a program and execution mode, the shift mode. In RPL you don't. You edit an object like you would edit a number. So what does it look like? Well, first of all, you have this command line, and what is nice about a command line is that you have a command line history, also 8 deep. And so you start typing a command, and you realize, oh, my daughter is crying. You exit the thing. Ah! You lost your perfect. No, you lost nothing. It's in the history, even if you cancel it. So you can go back and edit again and restart where you left. All the numbers you enter, everything. Now, there is one bug in this history, is that if you use the catalog to complete something, the completed version doesn't show up on the command line. That's a bug. I'm going to fix that. The feature of the HP50G, which even when I read the description, I don't know what it is, except that R, and K are the initial of 3 mathematicians. That's not the way to name functions. So, by default, DB40LX gives long names to things, but it does know the short names as they exist in RPL today. And when you type the short name, it expands to the long name automatically. Now, if you really prefer your programs to be dense and compact on screen, you can select, you have all these display modes, where you can display the commands in the RPL style with a choice of whether you want it lowercase, uppercase, or capitalized. Or you can have the long form. The head is even smart enough to recognize your preference. So if you should say short form lowercase, the head displays the name of comments in short form lowercase and shows the other names on the right so that you know what the other possible spellings are. So let me show you the head again. See, so that's when I have the long form, I have the short form on the right. Short form, I have the long form on the right. Okay, so the editor is designed so that you can edit things very quickly, and so you have things like moving a word left, right, you can move up and down with shift and arrow keys. You can search for stuff, there is a search button, so you can, you see the cursor is going to become gray when you search for something, and so you can move forward like this, and you have this cursor selection swap that lets you swap the position of the cursor in the selection, and then you search backwards. You can select stuff and do copy, paste, etc. And that works for anything. That works for numbers, that works for text, that works for pieces of a program, etc. And when you're running the simulator on your PC, it works with your PC. So you can type some RPL code in your favorite text editor, copy it in the simulator, save it on disk in the simulator, transfer that to your DM42, and here you go. Now, I told you about the transient alpha mode, where you hold the arrow key and you have F1, you have ABCD, etc. What happens with F keys? Well, what happens is that you have the editor commands. So once you have learned where the editor commands are, and the next generation of the overlay is going to have a little gray reminder that where the commands are. So you have select, word left, word right, search, copy, cut, paste, and the second level with left arrow. The HP48 introduced something very interesting, which was called the interactive stack, where you move up and down the stack. And it's funny because it's a feature I practically never used. And then some guy said, yeah, you know, HP48 is nice, but it doesn't have the interactive stack. So I started using it on the HP48. It's pretty damn cool, actually. You can do tons of stuff with it. You move it up and down in the results, which is neat. But you can edit things, you can evaluate, you can create a list with it, you can sort stuff, etc. So I went wide on this. There are more features now in the HP48 interactive stack. But you can sort all your stack values, for instance. You move up the stack and you say, sort between the bottom of the stack and here, sort all the values. You can show anything also. The show button, which is here, shows something with all the digits and as big as possible. So for all eyes like me, you have a tiny result on the stack. You move up the stack, you hit show, and you get it full screen.
You have an unlimited stack in this.
Yeah.
One more question. If you have done something to your stack, like sorting it, can you go back to the original one? Because
Yes,
you might want to preserve it to show the way you did your...
Yeah, so there is an undo feature, and when you enter the interactive stack, it saves for undo, so if then you hit undo after exiting, you restore the stack as it was before. The undo at the moment is only 1 level deep. New RPL has it 8 level deep, but the problem is that it keeps objects alive in memory quite a bit, and it turns out that the HP50 has way more memory than the DM42. The DM42 only has 70K free RAM, so I have to be careful about features that consume a lot of RAM by keeping objects around. So this is one that I draw for now, is the history for the undo stack is only 1. So RPL expressions, what does that mean? It means that you can build algebraic expressions using RPL. So you type x, enter 3 times, and then it shows 3 times x. And then 1 plus, etc. And so you can build your expressions that way fairly quickly, and you see that there is a beautiful graphical rendering, which, by the way, is a bit faster than HP48.
Which is?
Quite a bit faster than on the HP48, so it makes it usable.
I don't think so. equation writer was always so.
Exactly. And so now you have something that is like the equation writer, but really fast. I mentioned that some keys have multiple meanings depending on what you're doing. So the magic space key does evaluation inside the space when you're editing. It says an equal sign when you're inside an expression. And well, I was at the end of this section, so it's perfect. One last thing that I'm pretty proud of, because I think I invented that, I think it doesn't exist anywhere else, is the sample key. So what happens when you hit EEX, the exponent key on any HP calculator today?
Just do the next.
The E key,
Oh,
the one for the exponents.
yeah.
EEX. Yeah. So if I do that on HP 48, it does something totally useless, which is it inserts a 1 and an E behind it. I never did that once in my life.
So if you start entering a number with this EE,
Yeah. It starts with 1E. And I don't know about you, but I never had to use that. So I repurposed that feature, and what it does instead is it introduces a new, it's called cycle. And cycle tries to cycle between representations of something on the stack. So for instance, if you have a list, it turns it into a vector, into a program, back into a list. If you had a complex number in polar form, it turns it into a rectangular form, and conversely. If you have a decimal number, it turns it into a fraction, and conversely. If you have a unit, it cycles between the sizes of a unit, between centimeters, kilometers, meters, etc.
That could be a big loop.
So for units, it can be a big word. And that's the end of that section, so we can eat pizzas now.
Perfect.
Thank you.